This morning we're going to talk about port security, and this says secure network devices. We're going to look at, instead of using the single password, we have the enable secret password or the enable password, the unencrypted one. We're going to be able to assign usernames and passwords for individuals to be able to get on the network. And this, today ICND1 is a local database, so it's going to be called login local instead of what we're going to do. But the first thing we want to do is to do port security. What I like to do to start this one out is go through, and I like to do demos, is go through a demo of how this thing works and why it can become important. I've got a laptop over here, and let's say that you're the network administrator at a university, and students come in, they've got a wireless network, but all the wireless is just too doggone slow. I don't want to do that. So they come in and unplug your device, and then they plug in their device to your network. Hey, they're on your network. We don't have a clue what kind of protection is on this device. Does it have an antivirus software? Is it up to date? What's going on with it? So, it can be kind of a hazardous situation there. Let's put our device back on it. So we're going to plug us back in here. Fast Ethernet 03 is, I think, where we were. So how can we protect ourselves from these problems? That's what port security is about. What port security kinda is a MAC filtering for a wired network. You can do maybe have configured MAC filtering on a wireless network. So, and it's a kind of a pretty straightforward process. We'll go in here and go into config T. First we have to specify the interface range, the interfaces that we're going to put it on. And let's put it on all of them, 01 to 24. And then we're going to do switch port security. Switch port security to turn it on. And I don't know, you have to do this for both of them. Switch port security to turn it on. And then we're going to, is a dynamic port. Hey, we can't do this on a dynamic port, DTP, dynamic trunking protocol. So the first thing we have to do is make these access ports. So it'll be switch port mode access. Now then, we should be able to turn on port security, and to minimize typos, up arrow key recalls the commands. Okay, now I can turn on port security. There are about 3 things that I can configure in port security. The question mark here is the aging. The MAC address and aging we're not going to work at. Aging, these things are going to age out. MAC address, maximum value, and violation. So the MAC address, how are we going to get the MAC addresses on this thing? And the answer here is that we can type them in. We could leave it alone. We could not specify anything, and they're going to be dynamic addresses. They're going to be detected as just like we saw earlier in the week, as the frame comes into the switch, they'll be detected and associated with that port. In port security, once we turn port security on, we disable the countdown timer so that they're going to stay there. Unfortunately, power failure, somebody trips on the power cord, something happens to the switch and it gets restarted, they'll go away. What the sticky does is kind of goes through the same process, but it associates that MAC address, and we're going to see that, with a particular port, and it becomes part of the configuration. The HHH there is if you want to type in the 48-bit MAC address yourself, which I never wanted to do because I make too many typos. Sticky, and then we can do the carriage return. So we have sticky MAC addresses. The other one is switch port security, is how many do we want, how many MAC addresses do we want to be able to be assigned to, attached to any of these ports. And I'm going to do one here. One is the default. I'm going to do one because I have a hub in there. I'm going to show you what happens if we have too many addresses on one. So we can do the maximum. And if you do the maximum here, it says, 1 to 132. 132, that's quite a few addresses that are going to be there. That would be on an uplink port, a trunk port. But if you think about uplink port, trunk port, if I have port security configured on all my access ports throughout my device, why do I need to do any security on any of the uplinks? And actually, since it has to be an access port, never mind. We could do that, but do you really need that many? I'm kind of into less control each of the access ports. How many do we want to have? In our case, we wanted one, except for the ports that we used to run virtual machines on, when you had to have more, because the virtual machines have their own MAC addresses. They have to be able to get there. So we do the maximum of 1 here for these things. The other thing is, what happens if we get too many of these things on it? In the violation here, we can say protect, restrict, or shut down. Protect and restrict basically do the same thing. They just don't forward the packets, which to me gets, and I've done it with this one, it gets really confusing. Like, what's going on? Why can't I get these packets? Oh yeah, I forgot to have port security on this thing. Shutdown gives you, not only keeps the data from flowing, but gives you an indication because it's going to shut down the port. The technical term for it, for the shutdown, is air disable mode. But we're going to, and it also is the default. So shutdown. And if I go in here and show port security, it says, hey, the maximum address is the current address count. We don't have any on them yet. The security violation count, nothing here. The shutdown over here is not the port status. It is the security action. If we violate what goes on, what's going to happen with these things. So now let's go in here and see if we can make a mess. So IP config, I think it's the one network. Yeah, let's ping 192.168.1.255. Let's ping the broadcast address of these things. And we're getting there. We're getting replies from, oh, looky here. This guy over here is red. It's been shut down. It's in their disable mode because I have a hub here and I'm getting the 2 MAC addresses on this single port. So my violation worked. We can go back in here and look at if it did. Let's do the show run, and we have switch port security, MAC address sticky, and then we have the MAC address that's going to be associated with this port. If I now copy the running configuration, copy run start, and somebody unplugs the switch or does whatever to the switch, those MAC addresses will come back. If and we'll plug our little guy in here in just a second. If it comes back, then we have an issue. But let's try to get this hub working here, and it's Fast Ethernet 04. What I can do is to go into Internet Fast Ethernet 04 and do switch port security maximum. Oh, let's do 3 just to give us a little bit of an edge here. Nothing happened. I can try the no shut command, change state to down, and if we look here, it's still up. In port security, these things are not really down. Shut down is what we call it. They're what is, again, technically air disable mode. Let's see if we can see that. Let's show interface Fast Ethernet 04. When we look at it and you look at the line protocol is down, it says air disabled, which says that, yeah, you can't do anything. In order to get it out of the air disable mode, I'm going to go back into it, config T, interface Fast Ethernet 04. I do a shutdown, administratively down, and then a no shutdown, and it brings it back up into the up state with this thing. And now if I go back and do, and what we didn't do was show port security while it was down. Port security, and we can now have 3 current addresses. Says it has 1 because it would only take the 1, and before I did the shut and the no shut, it would have had a security violation here of 1. So now then we should be able to, and this is 51 and 53, and I think that they used to flip on me. Should ping the 52. Let's see, ping 192.168.8.1.52. So we get this guy, and yeah, now we're okay. And when we go back into this one and do the show port security, I've now got the 2 MAC addresses on here, 3 with the maximum that I can have on it. So port security. Now then, our student comes in and unplugs my machine and plugs in his machine, and we go to Fast Ethernet 03, and it doesn't work. He's now just shut down the port. So not only do I know that violated the acceptable use policies that he signed that he would do, because it says that you can't plug your stuff into our network, he also shut the port down. He's not any harm to me. I don't have any real danger at this point in time from an extraneous device on my network. So we have that capability here to do it at layer 2, and I've always been a kind of a fan of anything that happens at layer 2. I don't have to worry about it at the other layers. So if I plug this guy back in, though, it's not going to come up automatically. We're still going to be down. I've got to go in here, and I should be able to go in here to the config T and interface Fast Ethernet 03 and do my shut and no shut, and we're back up in business with my device. If you change NICs in the machine, you got a problem here, obviously, because now you've got to go in and take the sticky address off and allow it to redetect. You also got to have these things detect with a sticky at a time when only your devices are eligible for it. So we have those capabilities, the capability to manage some security at layer 2. And if we fix it at layer 2, hey, we don't have to worry about it at layer 3 or layer 4, because we already shut this guy down, or the application layer. So port security, and again, hopefully we'll go through the slides and just say, oh yeah, we did that. I saw that in the demonstration. Allows you to restrict the number of devices that may be cabled and connected to a particular interface on the ports. The maximum how many we can have on that. Uses the source MAC address, just like we did to detect the MAC addresses as it comes into the port. Detects the MAC address to check it to see if it's now associated with that one. We can either use dynamic, which we've had before, the dynamic detection. And you notice that the sticky uses the dynamic process, but what I didn't look at, those now become static addresses and not dynamic addresses. Let's look at that real quick when we do that and show the MAC address table. See, these are static. This dynamic here is the router on the gig port. We didn't put the gig port into the port security. So all of these are now static addresses. If I save the start up configuration file to, or the running configuration file to the startup configuration file, they're going to be there for as long as that config file is there. So they become static addresses. Uses the source. Port security has no restrictions on whether the frame came from a local device or was forwarded through other switches. That's where the 1 to 132 addresses comes in. But if you configure port security on all of your switches, and you know that only your devices can get on to all of the ports that are configured, and if you have empty ports that don't have anything on them, you really should put them into the manual shutdown mode so that they can't get from any place to any place else. And then put them on a black hole VLAN so that, you know, we have our devices on our VLAN, whatever we're using, and we have all of the unused ports on VLAN 99 or 999 or whatever you want to use. Somebody plugs into one of those, they're out in left field somewhere. They're someplace that they can't get back to because we don't have a router configured to route VLAN 99 to anything else. Also, shut down those ports. Double safety on those things. So, doesn't care where it came from, but again, my contention, and yeah, it doesn't matter where it came from, testing purposes, for reality, practical purposes, if you have properly configured your switches, shutting down all the unused ports, putting the unused ports into a black hole VLAN, and having port security on the access ports that you're using, then you shouldn't really have to worry about anything coming from another switch. But you can do that if you want. The thing at the bottom there, what we did, switch port security maximum, switch port security MAC address. If you want to type them in, personally I like sticky. You just have to do it when your machines are there. Turn the machines on, packet comes in, frame comes in, puts that address on it. And if it's a Windows machine, it can't not do something because Windows can't not broadcast. It will get them there relatively quickly. Determine which frames to filter using 3 basic methods. Limit the specific MAC address that can be allowed to send and receive frames on a switch interface, and discard frames to and from other MAC addresses. Limit the number of MAC addresses that are allowed to use the interface, and discard the frame. And a combination of the two values. The switch port security is what we used in a maximum. Switch port security maximum is what we use to define the number of MAC addresses that are allowed on an individual port. The MAC addresses themselves, and each of these with port security are going to be called secure addresses. So static secure, switch port security MAC address, interface command, stored in the table and added to the running configuration file. We type them in, static secure. If you have, 4 or 5, probably not such a big deal. If you have 400 or 500, becomes a much bigger deal. Even if you have a couple of hundred, it becomes a much bigger deal. You don't really want to type all of those in. And then if you change the NIC or you move a machine from one port to the other, one room to the other, one switch to the other, you've got to redo the whole thing all over again. It's something that, and our networks tend to be pretty stable. People come to work every day to the same machine and they log in. So the networks generally tend to be pretty stable. Occasionally you change things. You may add a room and add a VLAN or add a LAN, an IP network or something like that, but that doesn't normally happen every day. Statics, yeah, if you want to type them in, but to me the sticky secure essentially does the static for us, does the work for us. The system does the work for us by detecting the devices. The issue here would be is if you're configuring this when the guy with the laptop is plugged into your switch, then you have an issue because you're going to have his MAC address instead of your MAC address. Got to go back and do those. So we have the static secure, we type them in, sticky we looked at, and then the dynamic secure, which is the default. You will notice that, and I'm going to go back to this. Notice that, and I've talked about and said, and maybe this one will kind of show it. If we do the show run here, that the only thing that's in the configuration is the switch port MAC address sticky. Here, maximum 3. If I go to these others, only the sticky. The default maximum is 1. Even though I typed 1 in for the maximum, it's the default. Defaults don't show up in the configuration file. When I changed it to 3, the non-default value, it shows up here. The dynamic, the sticky secure, the dynamic, not sticky, the dynamic is the default on these things. So sticky shows up because it's not the default configuration of these. So in Cisco, anything that is the default configuration won't show up when we modify configs. or when we, even if we type modify, if we modified it, would be different, right? If we type, even if we type that command in and it's the default, then it's still not going to show up in the configuration file. So we have 3 different types of MAC addresses. The static everything was we type it in, and static was whenever we did static VLANs, we typed it in. Static, we typed the MAC addresses in. If you like to do a lot of typing, great way to go. The dynamic secure was the default, detects them. It actually turns off the count, the timer for these things. And I think the next slide is going to probably show that, or one of the slides here in a few minutes will. Turns off the timer when we do port security. The static secure automatically detects, becomes part of the configuration file. Becomes part of the running configuration file. And you're going to see some things that say, oh yeah, it will survive a reload after you copy the running config file to the startup config file. Because when it detects it, it doesn't say, okay, this is going to go into a table and it's going to be there until you change it. It's going to be in the running config file. You have to copy it to the startup config before it will survive a reload. Certain guidelines, port security can only be configured on static access ports. Saw that when I didn't make it an access port, when it was a dynamic port, DTP, the dynamic trunking protocol. Negotiate, you can't put port security on a dynamic port. It has to be, it says, can be configured on static access or trunk ports, either one, and that's why we had the 1 to 132. If we want to put it on a trunk port, we can, but again, if you've got it configured on all of the ports on your network, why do we need it on the trunk ports? You can do that. There's an awful lot of MAC addresses on a single port. And the MAC address tables have limited size. Cannot apply it to a dynamic access port. And that was, I do forget that. I kind of forget that, and I'm glad I forget that, because you can see when we do it on purpose that it says, hey, you can't do that. It's a dynamic port. A dynamic port we can't do. We had to go in and give it switch port mode access in order to do that. Cannot secure the port as a destination, secure port as a destination for a span. Span is switch port analyzer. We haven't done that. It's sometimes called port mirroring, where we watch the traffic on one port, maybe outgoing traffic on a different port that's not outgoing. Because in a switch, we only see the traffic that is to us and the broadcast traffic. Well, if I want to monitor everything that's going on this switch, then I've got to be able to mirror it or send a copy of all the traffic to a different port. And span or switch port analyzer is the process that does that for me. And we'll do span ports in ICND2. A secure port cannot belong to a fast ether channel. Another term that we haven't talked about. Ether channel, fast ether channel, gigabit ether channel, or when we group ports together to act as a high-speed port. In other words, if we put 3 or 4 gigabit ports into a gigabit Ethernet channel, we had 4 of them, we'd have a 4 gig virtual connection going between the two. Another thing that we'll do in ICND2 is create ether channels. Changing the maximum secure address value for an interface, specifying a new value that is greater than the existing value, overwrite the previous value. We did that. The previous value was 1, shut down the port. We put in 3, it took the value. If we had 3 in there and it was disabled for whatever reason, we have 4 or whatever on it, and we tried to put 2 on it, it won't take that term. So it won't take 1 that is less than if it's already in the air disabled state. And it was, as you saw, air disabled, which means that we've got to do the shut and the no shut in order to make this thing work. Let's see, override the previous value. Newly specified value for the interface is lower than the previous value and is also lower than the number of currently configured secure addresses on the interface. It's going to be rejected. The static secure or sticky addresses cannot be configured on the voice VLAN. And then Cisco switches don't support port security aging of sticky secure MAC addresses. The sticky secure The sticky addresses are there. They don't age out. They don't go away. And honestly, when we get to, and there is a slide here, port security disables aging in general on this thing. The advantage of sticky over dynamic is sticky will survive. Once we save it, will survive a device reload. The static secure, which is the default, or not static secure, the dynamic secure, which is the default, won't survive the reload. They'll have to be redetected. Interface on voice VLANs. Voice VLANs only supported on access ports. You can configure voice VLANs, and this is really kind of silly. It's only supported on access ports. You can configure voice VLAN on trunk ports. It's not supported. Okay. When enabling port security on an interface that is also configured with a voice VLAN, you need to allocate 2 or more secure devices in addition to the maximum. The phone's going to have a MAC address. The phone may actually show, its MAC address may actually show up on the voice VLAN as well as the data VLAN. And we can configure these things on a VLAN basis. 2 additional secure, and maybe 2, and you may not need to do that. You may need to do that. When you connect the port to the IP phone, will require up to 2 MAC addresses because it may appear on both of the VLANs on that particular port if we have the voice VLAN configured on it. Let's see, the address of the IP phone that is learned on the voice VLAN may also be learned on the access VLAN. Yep, said that a couple of times. Dynamic port security is automatically enabled on the voice VLAN when any type of port security is enabled on the access VLAN. So it's going to be an automatic there with these things. The static secure addresses, we type them in. You manually add them. We type in the 48-bit MAC addresses. Actually, if you were going to do that, probably maybe get a good ARP table and do a copy and paste of them. But type them in. You manually add them. You manually remove them. If we change, even if we had static stickies, and we used to use stickies, if you put a new NIC in, change a location, move a machine around, you have to remove with the no MAC address sticky, take that address off and let it redetect the address. So you may have to manually remove the address if you move things around. If you change the configuration of interface to act as a layer 3 interface, it's going to go away. That's going to be in a layer 3 switch, multi-layer switch. And the way you do that, if you want to make a switch port on a layer 3 switch, a layer 3 device, you go into the interface and give the no switch port command. When you make it do the no switch port, it becomes a routable interface. 3 types of addresses will not affect the dynamic secure. These types will not affect the state of the dynamic or the sticky. And the layer 3, if you then take it back to a layer 2, it will resume its previous configuration. The secure addresses, dynamic secure addresses on these things, when enable port security, by default the dynamic secure is what's there. It's the default. We did the sticky, and we saw sticky in the configuration. Maximum was 1. We didn't see it until we did the 3. We saw the maximum. If we had left it as the default, it would be a dynamic secure address for these things. Secures the MAC address when ingress traffic passes through the interface, detects it just like the switch did if we didn't make any changes to it, the switch. Dynamic ages the dynamic address and drops them when the age limit is reached. It says that, and then the next slide is going to say, well, not exactly true. Dynamic secure MAC addresses do not persist through a device restart or through restarting an interface. And then we go over here and it says, methods for determining the MAC address age, inactivity or absolute. The Cisco devices will age the MAC address learned by the dynamic method and drop them from the MAC address table when the age limit is reached. The age limit 0 to 1440 minutes, 0 for disabling aging, can configure the method either inactivity, the length of time after the last packet, or absolute. The absolute, it just does a countdown. It may need to change the aging timer from 0 minutes, which actually disables aging in the default. So that's the time. Let's see. This is the default aging method, which is the 0. So we may need to do that for the dynamic MAC address aging in here. And that's where I get the, yeah, it really doesn't age these things out. The static secure we did, and we probably have beaten this one into submission. The dynamic, or the sticky, is where we configured as sticky. It detects the first address in, or presuming it's 1, puts it into the configuration file, and then we can save it, and it will survive a device reload. Enable sticky, the device secures the MAC address in the same manner as the dynamic address learns it as it comes in. Addresses learned by the sticky method are available even after device restart. And this is the one, and it's kind of deceiving. It says like, well, I don't really have to do anything. It'll survive a device reload. No, it won't. We have to copy that into the startup config file. The only thing that's going to survive a device reload is the entries that are in the startup configuration file that are in NVRAM. Dynamic MAC addresses are not displayed in the running configuration file of an interface, whereas the statics are. Dynamic and sticky addresses learning are mutually exclusive, which means when a sticky learning is enabled on the device, we'll stop using dynamic learning and instead perform sticky learning. Same process. In the same manner, when you disable sticky, it's going to go to dynamic learning. So if we wanted the dynamic, we want to go back to dynamic, we could do that. The device will not age the sticky secure addresses. They become part of the configuration. So obviously they're not going to age out. They're going to be part of the configuration that is actually added to the device itself. The maximum, max MAC addresses, and we did that, maximum number of secure addresses that are allowed on a port. Default, a secure port will have only 1 MAC address. Even though we typed in the 1 in the configuration that we did, it didn't show up in the config file. The defaults don't show up in the config file. When we changed the max to 3, it did show up there. You can modify this default by specifying the value of 1 to the maximum available MAC addresses that are allowed on a switch. The one that we were using was 132. That's not the absolute. Each switch is going to have a different number of addresses that are available to it. Total MAC addresses, when we do that, after setting the maximum on a port, you can include the secure addresses in the address table in the following methods. Switch port, port security, MAC address, type them in. Port security MAC address, the VLAN range configuration command. For trunk ports, to configure all the secure MAC addresses on that range of VLANs. So we can, on the trunk ports, we can limit it by VLAN if we need to do that. Some of the addresses to be static and allow the rest to be dynamically configured. Different combinations of addresses. And these are, depending on the type of address, type of network you have, a lot of flexibility here in these things are allowed for what kind of things that we're going to do. The violation actions maximum number, and we did that, is reached on the secured port. The MAC address of the ingress traffic differs from the identified secure address. Wrong one, guy plugged his laptop in, or we exceeded the maximum number. We did both of those. Then we're going to go into whichever violation action that we have. And the shutdown, you notice that the shutdown wasn't part of our configuration. Shutdown is the default, which puts the port into error disable mode. Traffic is configured or learned on a secure port. Attempts to access on a different port in the same VLAN, the port security detects the situation, and this is known as a MAC move violation. What they're saying is we have a device plugged into it and we change it from one port to the other port, the same device, and we have these guys over here. Let's see what happens on this. that's going to be a secure, a violation of these things. And this was the one I remember is, we're going to say no here. Let's unplug this guy from that one, and then let's plug him into one of the other ports. Let's go to 9. He's now, let's see, he probably has his MAC address. We didn't do anything yet. Maybe we did some traffic. Let's see what the MAC address table tells us. What that is saying is that we can move it around. MAC address table. Yep, we have him on 9D5, and you notice that he's not on 3 anymore. He was already detected. Yep, this is an allowed MAC address. Let's just move it, but it is an error. MAC move error when we do those. When and if we do those, known as a MAC move violation. The violation methods are protect, restrict, and shutdown. We saw shutdown, we talked about those. Protect, it'll drop the packets. Protect and restrict are pretty close. The restrict perform the same actions as the protect. In addition, it's going to say, in addition, the security violation counter was incremented. A syslog message is going to be generated, and if we have SNMP configured, it'll send us an SNMP trap message if SNMP is available. Shutdown mode puts it in error disable mode. We call it shutdown. It's not technically shut down. In order to get out of that, we have to give it the shutdown command and the no shutdown command in order to reactivate that after we fix the issues. The step-by-step, I think that I'm going to say we did that. Switch port mode access, switch port mode trunk, whatever we did, switch port security, interface, subcommand. We did all of the interfaces. I set the interface range, and then we did switch port security. Actually, we did switch port mode access in order to set the mode to the access mode because they're dynamic by default. Switch port security. Maximum, we did that just to show a couple of things there. Switch port security violation, we did shutdown, which was the default. We really shouldn't have had to configure that. Then switch port security MAC address, and we did the sticky on those because, to me, and that's just me, it's the easiest way to get the MAC addresses into the system and then save it to the configuration file. Error disable. And we only got a couple of slides, and then we'll get into the labs. Error disable feature allows the switch to automatically change to an error disable state in the violation when the violation mode is shut down. We saw that when we did the show interface fast Ethernet 01 or 0, whatever it was, 4, that it was in error disable mode. It means it's not sending and receiving data. It's technically not shut down, but it is unusable. The mode name is shutdown. Configuration shows the port as enabled, and that's going to be the difference between it and shutdown. If we shut it down, it's going to show as disabled. It doesn't show as disabled. It shows it's still up. It's just not sending traffic, which effectively is the same thing. This means an error on the port will cause the switch to automatically disable the port. Any port error disable mode by the switch is effectively shut down and won't be able to send and receive traffic on it. And we can do in the show interfaces command, it'll show up. We looked at that as the error disable mode. Serves two purposes, helps the administrator know when there is a port problem, and that's what I told you earlier. If we use one of the other methods, it just starts dropping traffic. There's no indication on the LEDs on the switch that something bad happened. If you use the shutdown, it kind of gets everybody's attention. And it's not just students that do that. I've had people that have worked in the IT field say, it's not just these guys, it's the administrators that do this too. They bring in their own device. They want to bring in a wireless access point or a wireless router and use their own equipment or add more devices than they have. If you use this method, then they kind of get the message. Although we had instructors that would do the same thing. They would bring one in and try to plug in their own device, and then it's like, oh, what happened? And they don't tell you. You've got to look at the switch to figure out what goes on with it. But it protects you from what may be an infected machine, somebody plugging into your network. Anyway, back to error disable. With the shutdown, you can see that there's something wrong with the port, and you can't see that with the other two methods. Prevents the erroring port from causing the other ports in the module to fail. Yeah, and that is one of the things. To me, it's like when you're managing these things, you can see something's going on with it. Without the function, the other ports could fail if a bad port monopolizes the buffers, and that is all true when we do those things. Error disable recovery. This is an automatic recovery from the error disable. We did the manual. We went in and did the shut, no shut command. In order to get there, you can configure, not in Packet Tracer, but you can configure these things to automatically recover from an error disable mode after you have fixed the issue. If you've got, error disable recovery and you didn't fix the issue, it's just going to go back into error mode again. To recover from it, you need to first identify and correct the problem. If you re-enable the port before fixing the problem, it's just going to be disabled again. You need to use port security, dynamically learned and static MAC addresses in order to restrict the ingress traffic of a port. Can limit the MAC addresses that are allowed to send traffic into the port, restrict the traffic. After you fix the root problem, the port's still going to be disabled if we haven't configured the error disable recovery on the switch. In this case, we got to do the re-enable manually. We did that with the shut and the no shut. You can't just give it the no shut because it's really, again, technically not shut down. It's disabled by the process. If we enable the error disable recovery mode, automatic recovery on this thing, the command lists the general reasons that the ports have been put into error disable mode. So you have to tell it, I want you to recover after I fix these problems. And again, this is one that is not programmed into Packet Tracer. This is a chart of what are the default configurations. Port security, disabled on a port. The maximum 1, the violation mode is shut down. Aging is disabled by default in port security. Aging type is absolute. Static aging is disabled and sticky is disabled. So aging is disabled in port security. The defaults there, the maximum 1, the shutdown, the violation, the shutdown, and the type of what we get is dynamic, but it's dynamic with the aging disabled on it.